Welcome to Wolf Magic classes where mastering NCRT concepts are made easy and effective. Let's dive into today's concept. We have completed our chemistry first lesson. Now we are going to talk about gravitation since most of the students asked for this lesson. So we'll continue with gravitation. Chapter 9 Gravitation. Okay. So we have learned about motion of objects and force that causes the motion. So we have learned that force is needed to change the speed or the direction of motion of an object. We all know what is force. Force is nothing but a push or pull exerted on an object. So it changes the speed, it changes the direction, it changes the shape and size of the object. Okay, so we always observe that an object drop from a height where it comes down, where it falls, whether it will go there or it go at the side or right side or left side. No, it comes down. So from a height, if you drop something, it falls towards the earth. So we know that all the planets go around the sun. Moon goes around the earth. In all these cases, there is some force acting, right? The planets on the moon. Isaac Newton could grasp that some force is responsible for all these. So that is known as gravitational force. That's known as gravitational force. We in friction force we have learned it is a contact force. It needs two medium to be in contact. But here it is a gravitational force. It's a gravitational force. So Newton grasped that some forces acting on objects, the planets on the moon. Isaac Newton only grasp that there is some force acting. That's why they are moving, no? In this chapter, we will learn. In this chapter, we will learn about gravitation and the universal law of gravitation. It's an important question. So we shall discuss the motion of it under the influence of gravitational force on the earth. We shall study how the weight of the body varies from place to place. Yes, the weight of the body varies from place to place. We will discuss that also here. Okay. We shall also discuss the conditions for objects to float in liquids. So first we are going to talk about gravitation. We know that moon goes around the earth. Moon goes around the earth. An object when thrown upwards reaches a certain height and then falls downwards. It is said that when Newton was sitting under a tree, an apple fell on him. The fall the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the, is the force the same in both the cases? He has a question into him. And he conjectured that the same type of force. So then he found that yes, it's the same type of force. He argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. So it must be attracted by the earth. What is his question is asking that this is my earth and the moon's revolving like an elliptic light. It comes near, goes there, comes near, goes there. Why it doesn't fall inside? That is his question. So that's why something is making the moon to travel like this, right? It is not a perfect circle. It is not a perfect circle, but it something, there is some force which makes the moon to revolve around the earth. The moon doesn't fall towards the earth. So let us understand the motion of moon by recalling the activity. Take a piece of thread. Tie a small stone at one end. Hold the other end of the thread and you are going to give a motion. You rotate it. We used to do no. So note the motion of the stone. The motion. Now the stone will be moving around, around, around. Release the thread now. What happens when you release the thread? The stone will move. If it is in this position, it move. When you are releasing, if the stone is in this position, it will move straight towards. This is known as tangent. This is known as tangent. In the same manner, each and every point, at each and every point, the direction of the stone changes. The direction of the stone changes. So before the thread is released, the stone moves in a circular path with a certain speed. And listen carefully, children, changes direction at every point. So change in direction involves change in velocity or acceleration. The force that causes this acceleration and keeps the body moving in a circular path, where the force comes from the person. The person is standing in the middle, so it is from the center. The force is from the center. This force is called centripetal force. This force is called centripetal force. That means center seeking. It is from the center, no? So from the center, that's why in Earth is creating a force towards the moon, right? So it is exerted from the center. That's why the name is known as centripetal force. It is from the center. There is another type of force. It is away from the center. That is known as centrifugal force. If it is towards the center, it is known as centripetal force. If it is away from the center, it is known as centrifugal force. For that, I will give you an example. We go merry-go-round and all, right? Have you seen it? When you are rotating on the merry-go-round, the boxes will move away. That's why it is away from the center. It is known as centrifugal force. If it is towards the center, it is known as centripetal force. Is it clear, children? So we'll go to the next one. So in the absence of this force, I told you, the stone flies away along a straight line. So the straight line will be, it's known as a tangent to the circular path. That means a straight line that meets a circle at one and only one point is called a tangent to the circle. This is the definition for tangent to the circle. It's nothing but a straight line that meets a circle at one and only one point is called a tangent. So straight line ABC is a tangent to the circle at point B. So the motion of moon around the earth is due to the centripetal force. The motion of moon around the earth is due to the centripetal force. Centripetal force is provided by who is providing that force? Because it is exerted from the center, no? Earth is providing that. If there were no such force, the moon would pursue a uniform straight line motion. So it is seen that a falling apple is attracted towards the earth. I will ask you now, does the apple attract the earth? Yes or no? Does the apple attract the earth? Yes, it's obviously yes. Apple attracts the earth. Earth attracts the apple as well as the apple attracts the earth, but we cannot see it because the mass of the apple is very low compared to earth. Earth moves towards the apple, apple moves towards the earth. Both happens. So according to third law of motion, the apple does attract the earth. But according to the second law of motion, for a given force, what is that? Acceleration is inversely proportional to the mass of the object. Acceleration is inversely proportional to the mass of the object. So the mass of an apple is negligibly small compared to the earth. So we do not see the earth moving towards the apple. So extend the same argument for why earth does not move towards the moon. Yes, moon is also attracted by the earth. Earth is also attracted by the moon. According to the third law, no, we know for every action there is an equal and opposite reaction. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and the planets. From the above facts, Newton concluded that not only does the earth attract an apple and move, but all objects, yes, it's important. From that note, he identified that all objects in the universe attract each other. This force of attraction between objects is called gravitational force. This force of attraction between objects is called the gravitational force. So who gave an idea about this? Newton, right? With an apple he has discovered this, right? Now we are going to talk about universal law of gravitation. It's one of the important question as well as an important concept. Universal law of gravitation. Every object in the universe attracts every other object with a force which is proportional. Yes, what are the force depends upon the mass and the distance. So what is the relation? It's proportional to the product of their masses and inversely proportional to the square of the distance between them. So whenever an object attracts each other, they depend upon their masses also. The force is along the straight line joining the center of the objects. The force is only along the straight line. It starts from the center of the object. See here. This is A, this is B. The mass, they are different in their masses. So A we can capital as capital M, B a small one. Distance we are measuring in the form of D. So it's inversely proportional to D square. So let two objects A, B of mass m and m lie at the distance d from each other as shown in the figure. Let the force of attraction between two objects is Bf. According to universal law of gravitation, the force between two objects is directly proportional to the product of their masses. So F is directly proportional to the masses, and force between two objects inversely proportional to the square of distance between them. So directly proportional to the masses and inversely proportional to their distance. F is, we can combine these two equations. So F is directly proportional to proportionality sign m into m by d square. Instead of always remember children, for proportionality sign we should need to give a constant. So it is equal to G, capital G. Capital G is known as the constant of proportionality and is called the universal gravitation constant. So by multiplying the crosswise of 9.4, which gives F into d square is equal to GMM, right? M is nothing but mass of the objects. So G is equal to F d square by M into M. So the SI unit of G can be obtained by substituting the unit of force, distance for the D unit as well as mass unit. So it is nothing but for force, the unit. What is the unit of force, children? Newton. What is the unit of D square? D is meters or meter square. By what is the masses? Kilogram square. So it becomes nm square kg per minus 2 kg per square, right? The value of G was found out by Henry Cavendish by using the sensitive balance. So he has found out the value as 6.673 in 10 to the power minus 11 Newton meter square per kg square. So we know that there exists a force of attraction between two objects. Compute the value of those force between you and your friends sitting close by. Conclude how you do experience this force. Yes, between our friends also we can experience, right? We have some connect with them, right? The same thing. But here we are mentioning it in the form of name of force. That's it. So the law is universal in the sense that it is applicable to all bodies, whether the body may be big, small, celestial, terrestrial, anything. So saying that F is inversely proportional to the square of the distance. Then what it means, if distance gets bigger, what about the force? The force becomes smaller. So force is directly proportional to the mass. So mass increases, force increases. Distance increases, mass decreases. Okay, children, I hope you can understand this. So we'll discuss this problem tomorrow. Okay. So today what we have seen today, we have learned about how Newton identified that there is a force. Why the moon revolves around the earth, why apple falls down, why, what happens to it. Everything is attracted to, all object in the universe is attracted to each other, and he given a law known as universal law of gravitation. So I hope we have completed till this. Revise it once, children, then only you will be able to understand. Okay, if you have any doubt, reach us. Thank you for joining us at Wolf Magic classes. Don't forget to like, share, and subscribe to reach more students. Keep practicing, keep learning. See you all in the next video.